I want to talk with you about our software supply chain and the darker corners, how we can understand them a little bit better using the lens of community health. I'll start with one big idea, or really it's two slides. One is when we are looking at open source strategy, using open source, from what I'm hearing, there is three things that especially companies care about. The first thing they look at is the license. When open source got really started, there was a lot of scares around being sued for using an open source license or revealing IP and having to open source that as a result of using open source. So licenses have been around and understood quite well, depending on who you ask in a company. Security is the other pillar, and we have had Heartbleed and Log4j and several other bigger incidences that have raised the awareness that we need to look at the security vulnerabilities in open source. And the third pillar is the resilience of open source projects and companies. And that third pillar, from the conversations I have, has not been quite as established or has sunk into the mindset of open source strategy inside of companies. And so the lens that I'm taking is to look at the activity in an open source project as a predictor or prerequisite for future thriving of an open source project or success. Or if there is no one maintaining software, then it is for sure going to be abandoned. And that will cause problems. Now, I acknowledge there are open source software out there that don't have a community around there, that don't need a community. So there are nuances to everything that I'm saying, but this is the lens that I have. Why do we care? When we look at open source software as it is today, Sonatype found about 7 million open source components last year, of which they found about 10% being used. So there's a lot of open source overproduction or open source being released that does not make it into products inside of companies. This is noise. So if someone wants to pick an open source library or project or component, then they have to figure out, okay, what is that 10%? Or maybe they get something from outside. So there's a lot of noise. And similarly, of the open source projects, there's only about 15% or so that is being actively maintained. So both on the production and the consumption side, there's a lot of other stuff that we could be using that no one is actively looking at. And there are bad people that have discovered this to be a viable attack vector. So over the last years, there has been a steep increase in malicious packages published as open source inside of the package managers where we get our legit open source. And it's really hard to discover these. Across the industry, the cost of open source or just the supply chain attacks, software supply chain attacks, is estimated to be in the $60 billion this year. That's the current estimate. We'll see where it lands when the year ends. And if anyone says, yeah, well, that's the big companies, whatever, Gartner estimates that by this year, 45% of companies will have faced a software supply chain attack. So it's a flip of a coin whether or not we experience this. And if we take this not just at the industry level, but look at the individual companies level, what the impact is, we know from the SolarWinds example that there was an average 11% annual revenue damage to take care of the supply chain attack. So this is potentially very damaging to know or not know and secure your software supply chain. We already had the introduction. Thank you to Alan. My mission is to help open source become more healthy and sustainable, and I do this through metrics. So we'll be talking about metrics today. I want to talk through SBOMs, Software Bill of Materials, how we can trust what is in our own software supply chain. I have an example where we looked at dependencies of Kubernetes to exemplify this approach, and then I have some background on the technology that we used. All right, I want to start with a metaphor. Maybe you've heard this, that software ages more like milk than wine. It goes bad pretty quick, and the older it gets, it doesn't taste as good anymore. And when we look at dairy products, and we had a bad batch of milk producing yogurts, you can't go around to every store and try out, is this yogurt affected or not? You'll get sick to your stomach. So we have come up with a method of tracking where the milk was coming from, what farm it came from, where it was, whatever they do with the milk, and then being put into the final product. So that when there is a case discovered, we can go to the shelf, figure out the numbers, and pull everything off that is affected with the source milk. Similarly, we are in the process across the industry of doing the same thing for software right now, where when we build a product or service and we use open source software, which depending on the survey is about 70 to 95% of products, and I think that number is low. I think the remaining 30 to 5% don't know that they're using open source software. Then we really need to take a look at this, because open source software itself has dependencies. And when we don't look at those hidden dependencies or transitive dependencies, then we have unknown risk. This is why we need to take inventory, and this inventory is what we call a software bill of material. It's a list of everything that goes into our software. The software bill of materials, a little bit history here, got more and more attention, especially after President Biden had signed the executive order 14028 that demanded that anyone who wanted to sell into government agencies had to provide that inventory, that software bill of material. And CISA has been very busy over the last 4 years to build out resources on how to build the SBOMs. There are many different types of SBOMs. There's a lot of resources now available. And because it's government mandated, a lot of companies are starting to pick up on this. And the latest push comes from the European Union, where in the Cyber Resilience Act, they're demanding that any manufacturer that sourced components from others, including open source, has to do their due diligence, provide long-term support and updates, work in the upstream. There are a lot of demands that are coming. It doesn't say specifically you need an SBOM, but they say you need to know what is in your software, and you need to manage that. So how do we trust what is in our dependencies? How do we trust this? I'm going to give you another metaphor. Think of your car, if you have a car, and you're driving down the road, and the fuel light comes on. What do? You pull over to the next gas station, you fuel it up, you're good to continue. You have a dashboard that tells you, hey, I need, like, the engine light comes on. Okay, you go to the garage, you have a mechanic take a look, they fix it, and after an hour or two, you're ready to go again. This is for a car that is actively being maintained. After about 20 years, the manufacturers stop making replacement parts, and the garages don't want to work on it anymore, and you have an old timer. And I know people who really enjoy driving old cars and fixing them up, and they put a lot of time and investment into that, and they have their special friends that still can fix an old engine. But you start going to the junkyard for replacement parts, and it takes a lot of time and effort. And when we use this and apply it to software, we get a similar situation. When we look at licenses and security, those are things we can run a scanner against the source code. We can look for the licenses. We can look for, are there any known vulnerabilities? There are databases for this. And we can fix it. The resilience part is more where you're looking into the future, thinking, hey, will this still be maintained tomorrow? Or am I starting to see risk here? So this is why I believe there are 3 pillars, and we have different tools available to us for each of those pillars. And I want to focus on the resilience pillar, where we have metrics, community metrics, that in the Chaos project, since 2017, we have been building out standard ways of looking at open source communities and their maintainability and sustainability and the project health. And so this is where I'm going to take this next. And I'm going to put the thesis out there that tracking open source resilience is proactive risk management. And with resilience, I believe this to be the capacity of an open source project to overcome difficulties to continue producing quality software into the future. That there is that core activity of members that will keep the technology updated, that will respond to changes in the market, that will fix vulnerabilities as they become known. And when we look at this as part of our risk management practice, we want to pick those open source projects that have that resilience built in. Because if there's no activity, then the project becomes abandoned, and no one fixes the problems that we find, and it's just not good. I'll just leave it at that. So what do we look at? What are some indicators that we can investigate? This is where the fun really begins. As a first iteration, what we looked at was the demand. Can an open source community manage the demand that they are getting on new issues being opened, new pull requests being opened? Are they closing them at about the same rate? Or do they let things build up and the backlog becomes bigger and bigger? Which tells us there might be a problem with too much demand and not enough resources, volunteers, engineers working on the problems and solving them. The second thing we looked at was how quickly are issues and pull requests being resolved, the lead time from open to close, as an indicator for, well, let's say a vulnerability is found. How long does it take until we find a solution, a fix in the final release? Also, let's say I want to contribute to the project. How long would it take for me to go through the process of filing an issue, making a suggestion, requesting a feature, maybe working on a solution, filing a pull request or patch or a change request, whatever platform we are using. I'm just using pull request because GitHub is very popular as an example. And so we want to have that responsiveness, that things get worked on quickly. And the third bucket is talent. We want to know that the people in an open source project have the knowledge, they stick around, because the longer someone works in an open source project, the more they understand the architecture, the better they understand decisions that were made in the past and how certain changes might affect other parts of the system. So we want to have that retention of talent, but we also understand that in open source there needs to be a renewal, new people coming in. And we want to track how many active contributors are there overall over time. And then the last one, the contributor absence factor, which might also be known as the bus factor or the pony factor, making sure that it's not dependent on just one person doing most of the work, that there's multiple people sharing the workload. So we take these metrics, and this can be extended with other metrics and other things that we can look at, but we need to have, this is why I gave you these 3 buckets, we need to have a theory of why we want to look at these metrics and what they tell us, because later on you'll see how we can drill in and figure out what we can do to help open source projects. So once we have these metrics, we want to simplify it. We want to, when we look at a software project and it has 100, 200 components or dependencies, sometimes even thousands of dependencies, and across an entire organization, the numbers that I'm hearing are in the hundreds of thousands of open source dependencies that they have. There needs to be a way to filter, okay, where do I need to pay my attention? And so we normalize these metrics and combine them into one score. So each component gets its own score, and we just chose randomly from 0 to 10, and used our experience from analyzing other open source projects to know what are good ranges and where do things start to be risky. So we used our experience from analyzing other projects to build the thresholds when something gets a certain score. What we can then do by having these standardized, normalized scores is we can aggregate them. So we can say we have a software component that has a certain number of dependencies, and we can aggregate what is the risk score for that component and all of its dependencies versus another one. Again, the idea is to have some guidance on where do we want to drill down more, because the more we abstract, the more information we lose. And like all models and maps, they're only useful to an extent on giving us a direction, but they cannot give us the same information as if we go and we are in the actual place and look around what's actually on the ground happening. So this is that abstraction that is going on. So I'm going to show you an example. We looked at Kubernetes Golang dependencies, and I want to preface, it's not about judging specifically what's happening in Kubernetes. I just want to give you an idea of how this process, this way of thinking works. Okay, so don't focus on the numbers. Go with me on the process that we are going through. We built the dashboard where we have here a filter. So we can say we want to look at this component, or in this case, the Golang dependencies inside of Kubernetes. And we have, after we apply that filter, we can see how many of the dependencies do we judge to be low risk, medium risk, high risk, or very high risk. Again, the idea is that we can filter down on where we want to pay attention to, because we can't pay attention to hundreds of thousands of dependencies. And then we can see how that risk is distributed across those 7 metrics and the 3 buckets that we looked at earlier. The darker fields here just mean there are more components that fall into that risk level for each metric. On the left, we have low, in the middle, medium, and on the right, high. And then on the columns down are the 7 metrics. So what we can see here, there are several components that are in the high column, specifically on the growth of active contributors. So there seems to be something about just being stale, like stable, that it's not growing, or it's even declining in active contributors. And also with the pony factor, there are a lot of dependencies that have only one main contributor that does more than 50% of the contributions. I think the time frame we looked at was what happened during the last 12 months. So we always look at a period of time because what happened in the previous week is not that interesting. It's always a longer period of time that we look at. So while Kubernetes as a whole gets a lot of attention, when we look at the dependencies, we start to see, okay, there might be some areas that we want to take a closer look at. And we can use this also to drill down and look at individual components. So this is a different view then, where we see the overall score. In this one, it's medium. And we can see the raw metrics. So the more we do this, the better of a frame of reference we have for what the metrics mean and how they rank against others. But the risk value is our judgment, then based on our experience in the model we put in, to see what is low, medium, and high risk. And in this case, we see a lot of things look good, but the lead time is where the high risk is. So if I wanted to support this open source project, I know that I can help with closing issues and pull requests faster. When we look at the Backlog Management Index and the Review Efficiency Index, BMI and REI, which is the ratio of issues being opened and closed and pull requests being opened and closed, that ratio looks okay based on the history and the comparison that we have made. So it's not about there being too much work, but it takes too long to address the things. Or maybe they have old things that are staying open way too long, and someone just going in and helping clean up the old backlog would really help that project. So there are some things that we can do here, and I don't know this particular project. I'm just telling you based on the metrics what are typical conclusions that can be drawn. There needs to be that next level of investigation of someone going in, maybe talking with the community contributors. But it's a starting point. That's the whole reason why we are doing this, as a starting point. In a second iteration, we had a new question where someone said, so how can I see the projects that are most likely at risk to be relicensed? Relicensing is a problem because when a project becomes no longer to be open source because of license change, then we might not be able to upgrade, or we might be forced to pay support, or there's risk, business risk. And so the question was, how do we quantify that? And we added a single vendor risk metric, looking at the copyright inside of the code base. How much is that distributed? If it's all held by one entity, or mostly held by one entity because they had most of their engineers behind building the technology and they're the ones commercializing it, there's a very high risk that when they get venture capital and the investors say you need to take it back, even though you've already open sourced it and commercialized it differently, there's where a lot of the risk lies, based on the examples that we have seen over the years. So we quantified that, and then we also had one for vulnerability risk, looking at databases and known vulnerabilities. Oh, and also you see on the right, the different colors, green, yellow, red, ultra red. We've made that more like a stoplight, was another request we had. The next iteration that we are working on right now is bringing it closer to the developers. So the dashboard is good for a controller or a manager that wants to see what is happening across everything that we have in our software bill of material, in our dependencies. But if we can catch it earlier, that would be good. And so we're working on an implementation to get it into the CI/CD pipeline, where developers within minutes will get the feedback. So the CI/CD pipeline builds the software bill of material, which is something I hear a lot of companies are moving towards. And then we take that SBOM and enrich it with the risk scores for each component and return that to the developer, or specifically any alerts or warnings, or if it's over a certain threshold. There, of course, then needs to be some analysis where maybe a component doesn't get a good risk score, but it's the only thing out there. There also can be cases where quite the opposite of activity is what's wanted. I know a medical machine manufacturer that says we are using open source that was validated by research, and we have gone through the whole certification process. And if there is any change in the open source algorithms, whatever we are using, then we have to go through the entire certification process again. We can't sell the machines anymore. And so they're stuck on that version, and any changes are a risk. So there's nuances to all of this, which I acknowledge. All right. So this is the approach. We have looked at a lot of things together already. We've looked at why we care about our software supply chain, how the activity today can be an indicator for the success or abandonment of a project in the future, how we can look at some basic metrics to get an understanding, a basic understanding, and focus our attention. And so I want to talk about the technology, the open source technology that is behind what we built. The GrimoireLab software has its roots in research. Back in 2004, the LibreSoft team at the University Rey Juan Carlos in Spain wanted to understand how is it possible that volunteers on the internet are building high-quality software. That was fascinating, and there's a lot of research in that time looking at open source. And so they open sourced their tools and started a company around this because there was enough commercial interest to get insights and analysis into open source projects, and asking competitive questions like, if I adopt this open source technology, will I be able to contribute to it? Or what's the future prospect of this? In 2016, it was completely retooled to be built on Elasticsearch, so that the database, the structure of the data is very flexible, and there is a dashboarding solution already built in. Before, every time there was a new visualization, it needed to be hand-coded, and the SQL schema needed to be changed. So switching to NoSQL was the goal here. And I'm going to say already, we're going back to SQL because NoSQL is really hard for developers to think and get the data out. More people are trained on SQL, and so we're adding a SQL interface again. In 2017, we started the Chaos community to bring people in open source, companies, foundations, maintainers all together and build a standard around how we look at community health and metrics and the tooling. And last year, we released the first 1.0 version of this tool. So it's been in the making for a long time, and you see a lot of logos at the bottom from companies that have used the tool over the years. You may have seen the Mozilla Rebel Alliance report. It's a very beautiful report. I highly recommend taking a look at that. The data that is in the report about how Firefox is built, the Thunderbird community. One of the key things that I really loved that they did was look at the impact that their in-person events have had on the open source community, and really showing that people who come to events are more integrated afterwards and contribute to more parts of the project than otherwise. So there's a lot of cool things that we can do with this tool. It's also the foundation of other platforms that have been built on top of it. Biturgia Analytics, the Document Foundation has it. Mystic is a research project at the Rochester Institute of Technology, the Linux Foundation Insights platform built on it, and OSS Compass out of China. I think Gitti is behind that. The general process that this tool goes through is to take the data, collect it, and there it has more than 30 different platforms that open source projects are on, from, of course, GitHub, just Git repositories, Gerrit, GitLab, Jira, Confluence, mailing lists, Slack, IRC. The idea is that anywhere where the community is, we want to get that data, and then in the enrichment phase, normalize it, standardize it, where we can combine the data, and then visualize it and report it so that we can draw insights from it. The architecture looks like this, where we have a lot of cool names like Percival and Sorting Hat and Mordred and King Arthur. They all do their part. So the Percival, the loyal knight, is sent out to retrieve the data. That is the component that connects to the APIs and gets the archives and gets the raw data. That is put in JSON documents into a database, from which we then do the calculations and the enrichment. Because, for example, we might get when an issue was opened and closed, but we are interested in how long was that time in between. And so those are calculations that we do. Sorting Hat is a really cool module that we have, because who has ever used more than one email address? Right? I don't know how many. Or different usernames. And being able to say, hey, this is actually the same person in my community, and to say, okay, I also know what organization they work at. Now I can track the activity, the journey of someone through my community, but I can also see, because I can affiliate them with organizations, what organizations are active in my community. And I can see things like, okay, I see this very important company is starting to have fewer people engaged. And there's a lot of things that we can draw conclusions from with this information. I also want to do a quick excursion into being mindful about data privacy. The GDPR, the General Data Protection Regulation from the European, is like the gold standard. Other states here in the United States and other governments have adopted similar frameworks for protecting personal identifiable information and putting more rights to the people about their own data, like names and email addresses and login. And so the question we have to ask ourselves is, do we have to do opt-in to process this data, or can we do opt-out? And with open source, any contributor that contributes to open source knows that their name and email address will be associated with their contribution. That's part of the transparency that we demand and have established in open source. It still does not yet qualify us to analyze that data. We need to do another analysis and weigh the benefits and the risks to the person. And oftentimes, open source communities say it is more beneficial for us as a whole, as a community, to do an analysis of how the community is doing than the potential risk to the individual by processing that data. And so oftentimes in open source, we are allowed, even with GDPR, to do that data analysis, but we may want to have to talk to a lawyer to confirm that, yes, the rationalization is okay here. And of course, we need to offer anyone that says, hey, I see myself in this data, please remove me, that we have mechanisms, and we do in GrimoireLab, to remove someone and anonymize them again. A quick look ahead. What are we working on right now in this technology? GrimoireLab is on its way to 2.0. One of the things we are improving is the maintenance effort. right now to configure, there's a lot of configuration files that someone has to edit manually, and then it's a JSON document, and if you don't validate the JSON, then you break your installation. Building a user interface on top of that will make it easier. The other thing we are doing is scalability and performance. We built this initially to analyze communities from like the perspective of a community manager. And so if you have 50 or 100 or even 1,000 repositories, you're looking at a big community already. Now we are looking at an SBOM of tens of thousands of repositories, and it has to scale a lot more than what we used to have to do. So the scalability is something that we are working on right now. And then also integration with other tools, like what I was showing with the CI/CD integration, getting an API and other measures in place so that we can more easily integrate the data and make it available elsewhere, and the SQL interface that I was mentioning earlier. How to get started? The open source tool, you can go to the tutorial. You can find ways to get started there. There's a Docker Compose, and that's one way. We also offer commercial support if you're interested in talking with me about that. And so I want to close the talk by revisiting real quick what we've covered. We talked about how it is important for us to look at the whole software supply chain that we have. And there are parts that we just don't have the time to really pay attention to. So we need a way to know where do we need to pay attention to. And we've looked at security and licenses as important factors, but resilience as the third pillar. And looking at the health of open source communities, the activity in the projects as a guiding metric where to pay that attention, and how we can combine that into one score so we can compare across all of the projects, because every open source community is different. So we need to have some way to guide our attention. And I want to thank you for being here this morning. I hope you have a wonderful scale, and I'm happy to have a conversation for the next 20 minutes. So thank you.
Very interesting talk. Thanks so much. The sorting hat component seems like it would be able to produce data indicating reputational score of contributors. I didn't see that specific data, but it seems like it could, like potentially a aggregate reputational score for the project of the contributors, so that if somebody's contributing in positive ways to many different projects, that would increase their reputational score. And so basically trying to identify somebody who's trying to undertake a supply chain attack. So just wondering if that's something you're looking at doing.
It's an interesting question. We have, in our own analysis, stayed away from analyzing the specific contributors. I know there are people who look at the journey of contributors into projects, and it might be possible to do. It's something, especially since the XZ-utils scare that we had last year, where a lot of attention is, okay, can we understand what the individual contributor is, where's their background, where are they from, can we trust them? And I'm not involved in that work, but the data is the same, right? We have the activity level data, what everyone did. And so coming up with the algorithms or the ranking or the scoring or whatever analysis we want to do on it.
Yeah, so the left pad attack in 2016 was one guy, published a single library that was used by like tens of thousands of projects. And that he probably would have surfaced when he took over the project. So there would have been a change, right, in the contributor, and it would have been one contributor, and the median reputational of that one contributor probably would not have been high.
There's a second component to all of this analysis that we did not talk about today, and that is looking at the importance or the severity of or there's another word for it, for an open source component, how often is that represented in our software stack? How critical is it? How close is it to the outside? So what are the attack vectors or the use cases where reachability, all of those questions come in, where you may want to weight the risk score in different ways based on the exposure risk or whatever, exploitability, all of those things. So we didn't talk about any of that part of the risk analysis and risk management, but that's also part of it. Back there. And then
Thank you very much. Two quick questions. This is, first of all, how do you pronounce? No, GrimoireLab. The Grimoire. Is the GrimoireLab deployable within a closed cluster? It's open source, but I get the feeling the data behind it is what is really making it work. And the second question is, I noticed you were using Elasticsearch. Have you gone to OpenSearch? Is it just in our institution, people refer to something as Elasticsearch, but it's just the index search engine, and we mostly deployed OpenSearch, so changing habits is a lot harder than changing components sometimes.
yeah, thank you. To the second question, we have fully migrated to OpenSearch. I just forgot to mention it. Yes, we built on Elasticsearch. They changed their license. We wanted to stay fully open source with our solution. And so we switched to OpenSearch. Now that Elasticsearch is open source again, well, sorry, they missed the out on us. So, this first question. When you deploy GrimoireLab, it comes without data. And you configure it with, these are the community platforms that I want to look at. These are the repositories, mailing lists, archives, and so on and so forth. And then it needs access to that data. So it needs to be able to call outside, call the GitHub API, call the mailing list, archive, wherever the data is, to collect it. And then after a day or whatever the cycle is, it will go out and get new data. So it's not live active data. It is a little bit behind of what's actually happening in the community. For the purpose of the analysis, because we're looking at what happened during the last year, it doesn't matter what happened in the last 3 days. We're looking at a bigger time window, so it works. But you need that outside access for it. Over here and then.
Thanks, Georg. The slide that you had that you listed the 7 factors for the first time, has anybody done any analysis? Yeah, sorry. Couple more. That one. Medium lead time for pull requests. There's been a couple of projects now. I've seen Ted So talk about it with the Linux kernel, and there was a really well done blog post on Postgres. So key infrastructure projects where pull request times are getting longer because of the delicacy of the change to these critical components. So when you say there's a lot of nuance here, like, is anybody looking at that kind of thing yet?
The way that we are approaching the nuances here is we are looking at similar kinds of projects to figure out what are the thresholds to look at. And then over time, so we also had an experiment where we gave this tool to different departments, and different departments wanted their own risk thresholds where they know more about the components that they're using, and they said, no, we need to adjust what we consider risky and not risky. So there's an element of customizability that we need to provide to make it useful to the different teams. It's not one approach that fits everyone. It's a tool to help us focus on where we and sift through all of the components, because I've had conversations with engineers that said, by chance, I looked at this component. There was something that caught my eye, and then I realized, no, we need to change away from it because there was a contributor that was in Russia and whatever the reasoning was. And we need a more systematic approach, so it's not just by chance that we find these.
So it sounds like if there's multiple instances, yeah, is this good? Okay, we got. So it sounds like there's more than one instance that would be running out there, and more people run instances, and so the crawling of GitHub and mailing lists and other, would kind of be like maybe redundant work. So I wonder if there is maybe a common interest in kind of a common data sync that maybe could be hashed, and then those hashes could be anchored on the various blockchains so that we know that proof of existence, this collection of data at this time. Maybe there's a need for that. And then the other is a 3-day delay. My generation, millennial-ish generation, Gen Z, are, if it's online, it should be in our database. It should show up in the analytics. So how would there be any? What would be the anything in the way of getting to data that has a latency of like not more than a couple of minutes? Would be my other question. So.
Yeah, thank you. One of the issues is indeed that we right now have to run the analysis and collect the data for every different instance. There is no effort right now that I know of to create a central database that makes this data available to everyone. GitHub Archive is pretty close, at least for GitHub, to have one place for this. So the answer is, also I know other people are asking the same question. Hey, can't we just have one public metadata set about open source projects that we can all get to, and raises the floor for everyone, and everyone gets access to this, makes it easier and cheaper for everyone to do this kind of analysis. So those conversations are happening, but I've not seen anyone take that step. Did you have a question, or did you want to respond? Okay, I have another one there, and then back to you. And then the other question you had was about the real-timeness of the data. It would require a different data ingestion than what we have right now. It's very possible. One of the key challenges we run into is API keys being exhausted, and so we can't collect fast enough because of the slowdown that is being imposed. But you want a quick follow-up?
So if we have a common data sync, and it's kind of common to multiple players, then perhaps we can have multiple API keys that are throttled so that we can all kind of, yeah.
Yes, API key rotation and so on is something we're using.
Hi. I just have a question about the analysis of a dependency. Is it all about a static analysis on where are the package and when they are used, or do you have a runtime to, for example, check what are the packages that are actually be used in your application and what are the dead codes there? So do you have this kind of runtime, or it's all static analysis? And then I have just another question. Maybe I just ask this other one. It's about GDPR. Is it possible to do opt-in? Because I don't really understand how would be possible, as you have the main package, but then all the dependencies. So even one community is okay to gather the data, then you don't know that the others one are okay also. So I mean, it's quite complicated there to have GDPR compatible.
So to the GDPR question, doing opt-in, there are so many challenges with doing opt-in for the data analysis that no one has attempted it, at least no one that I know of, because there are many people that come to an open source project, they contribute once, and then they leave, and how are you going to find them, track them down, and ask them? They might change the email address might not even be there. They may have shown up in a forum, and you only have the username, and it's not even identifiable, which at that point it doesn't matter, because it's not PII. But still, you won't be able to get consent from everyone. And so opt-in, I've not seen an example where that has been done. What we have done in the Chaos project is we have a data policy for the entire project where when you join, it's on our website that says we also have a dashboard. So be aware, when you're here, your data also shows up in this dashboard because it's a community service, everyone can see this, et cetera, et cetera. To your other question about analyzing where components are being used and more of the severity question or exposure question, the approach that I was talking about today assumes you've already done that work and you give us an SBOM, and then we enrich the SBOM with the project health information. So that is a prerequisite step where you need to identify where am I using stuff. And I know companies that are storing their SBOMs, they can query them, they can see how often a package is showing up and where it's showing up and all of that information. But that's a different solution. I was talking about how do we get more information on what we're using.
This is kind of in reference to your question earlier. I believe Salsa is a project that is providing a defined SBOM format that could possibly be used for people to at least publish SBOMs in a way that would not require folks to individually need to go and generate them. So that could be one potential thing for you to interoperate with.
Did I understand it right that you're referencing a Salsa project that is helping with generating SBOMs?
Providing a format in which SBOMs can be created and interchanged. We're defining what an SBOM looks like.
Okay, so Salsa being a format for SBOMs. The two main formats that I see in the wild being used is SPDX, which is a Linux Foundation project, and then CycloneDX. And those two are the two that I personally see most of the time. I have not seen Salsa as an example.
There's lots of different organizations that are chasing this. CISA is an organization that's very involved with it, and they've got the SBOM-arama, and they've got a lot of working groups. OWASP does as well. But yeah, insofar as accepted formats, CycloneDX and SPDX are definitely top two.
Yep.
Looking at the slide, you might want to add sort of a section on financial stability, and perhaps as a high-level abstraction, you could talk to the project's term structure, kind of an aggregation of what kind of portfolio of financial contributors, if there are any, whether it's an independent developer, self-supported, kind of abstract that into what kind of a term structure the project has, longer being more stable, and but kind of a way to see into the finance angle of many of these projects, because that's an important need on their part.
So the question I have in return is how automatable is the data collection for that piece of information? Because these metrics are chosen because we can automatically collect them over a wide set of dependencies and libraries. Yes, those other questions around financial sustainability, who is backing the project, and so on and so forth. There's a lot of things that we can look at that are really important, but we can't automate it quite yet. And there's a funding YAML that projects can provide in GitHub where they can point to places where people can contribute. If they're on Open Collective, we can probably get data from there, but even that is not as widely available. And then we have a lot of foundations that don't reveal the financial status, but we might be able to find on the website who are the main companies that are paying for being on the board and so on. So the question is, how do we scale that analysis, or do we leave that to the next step in the analysis where we can use metrics that we can automate to help shine the light into the dark corners of the software supply chain and say, I want to take a closer look, and then when we do that analysis, we can also look at those other things like financial stability.
Just quickly, if a foundation is a 501c3 in the United States, you should be able to somewhat automate the process of requesting the 990s every year from the IRS and just sucking all the data from there.
That would be great if they filed them in a timely manner, and also if they were to provide that in a very detailed way, because a lot of the foundations have many projects, and you may not get the breakdown of how the money is distributed. So, yeah, it would be nice if there was a clearinghouse for that kind of data. All right, we will wrap this up. I thank you again very much for being part of this conversation. Thank you for listening to the ideas this morning and engaging with them. Thank you. So the slides that are on the Scale website are from before this morning. I made some minor tweaks this morning. I'll upload the current set later.